Would I be interested in taking notes for
everything-
the stuff that's
for
not
everything
mine?
that's not yours. And
Hey, look, the topic has been set to MBONED IETF 106. Is that just
we're
me?
going back to the
in the chat.
Back to the Future.
106.
If only.
That's what it says.
Those were
man.
heady days.
Yeah,
We used,
heady days. These are heady days too, man.
we would.
It's
We used to see each other.
yeah.
We used to be in a room back then.
That's true. We used to see each other. Yes, I forgot about that. Yeah. I can certainly contribute. I would need help, of course, for for the parts where I'm talking.
I'll cover that.
Great. But yeah, I'm happy to help here. I guess I will paste in the agenda.
Thanks, Jake.
Sure. Come on, man. I can't. All right.
All right, looks like folks are trickling in. So Greg and Jake, I'm sure everybody's wondering, did you get up or did you stay up?
Oh, I got up.
I got up too. Yeah. Last week I started on trying to be prog. I mean, this isn't real prog time. This is like be nice to East Coast prog time, right? which is actually really helpful for us on the West Coast as well. At least in my opinion, like it's way better to get up at 3 than it is to get up at 11:30. And but yeah, I've been doing it all week because it just works better that way.
I think we're
and it's not any worse than traveling.
We're at Prague lunchtime.
Yeah, which is fine-ish as long as you're not in the wrong. I mean, unless you're in Australia, I guess, but
fine for a week.
Or lots of places. Yeah, I mean, it's got to suck for somebody, right? It sucks a little for me. It could be worse. It would be nice if they integrated, like, hey, when you're speaking, it could be at the same time, but can't have everything, I guess.
We got the next one, right? I think the next one's in San Francisco.
San Francisco, yeah.
That'll be an easy trip for you.
From California, yeah.
All right, Greg, do you think we're ready to start? Looks like we've got a decent number of folks online.
Ready enough, yeah, absolutely. We got to get rolling. They didn't shut us down on Tuesday, though. We were about 15 minutes over, and we continued to roll. It was great. They didn't suddenly chop us off, but I don't want to push resources. Let's not shoot for that.
Well, actually, since we've got Lorenzo who's in charge of everything, so we can do whatever. I'm pretty sure we can do whatever we want.
He's in charge of everything.
He's the head.
Can I get more coffee?
Yeah, well, let not my colleagues hear that because they may disagree. But
don't worry, nobody's listening. All right, so why don't we get started here? Hold on here. Okay. Welcome to IETF 110-MBONED. You can all, I assume, see the note well. Please do note it well. Very important stuff. And I'm sure you've seen it multiple times this week. Should be the same. All right, here's our agenda. Mike's going to provide some updates. And one of MBONED's charters is charter items is to receive reports, deployment reports from folks who are really using Multicast. Really excited to have Oriole from UMetSat talk about their use of Multicast, and they are a true classic MBONE application. They are using Multicast over the RNE networks and delivering their content natively to customers across to their customers across true interdomain multicast routing, both SSM. They had done ASM in the past, not sure about now, but lots of interesting stuff that he's going to talk about. And it's an application of many of the things we've discussed over the years. So
Lenny, your slides are not advancing. You maybe have the wrong screen showing or something. I don't know.
Agenda? Do you
There you go. That's better.
Okay.
Yep.
All right.
Now I see it.
All right, maybe I just need to not go into presentation mode.
Yeah, if you're using presentation mode, in some cases, it becomes a different window that the browser is not able to capture. So it's still capturing the main content instead. Okay. So it varies from browser to browser, so it's hard to figure out. But if you remain with this view, you're probably fine.
All right, and hopefully everybody can just squint and see this okay. We won't be here for long. The next up, Jake's going to talk about his 4 drafts. And then Lorenzo is going to talk about how Meet Echo uses Multicast. Comments on the agenda? Bashing opportunities? Thoughts? Okay. Moving right along. All right, in terms of the status of the active working group drafts, the multicast problems, the Wi-Fi problems draft, problem statement draft has been revised to address the IESG comments. Mike's going to provide the latest update on that. The Yang models draft. Sandy, anything to say about that one? You presented that in 109. Any updates on that? Here we go. Sandy.
If I remember.
Yep. Yeah. We hear you, Sandy.
Can you hear me? Okay. If I remember right, Jake said that he will review the Yang model, right? Jake? I'm waiting for your review.
Sorry about that. I will get right on that then. Thank you for. I must have dropped that. Sorry. I will look for that review and make sure you get it by next week.
And anybody else?
Appreciate.
Anyone else who wants to review as well? I'm sure Sandy, you would appreciate other reviews as well. We have the multicast to the browser drafts. 2 of them were sent to Yang Doctor early review, which is misspelled. There we go. Misspelled poorly. The CBAC and Dorms draft were sent to the Yang Doctors. And Jake is the NAT draft has been adopted since 109. And Jake is going to provide updates on all 4 of those today. And Mike is going to Mike or one of his co-authors will talk about the telemetry draft. Other drafts, there was the redundant ingress failover draft that was presented in 109. Informationally, haven't seen, looking for comments at the time, haven't seen any updates or anything from that since. And anything else anyone wants to talk about? If not, I think we can go to Mike. I'm going to bring up your slides.
Thank you, sir.
Okay. Can you see the slide?
Yeah, can you hear me okay?
Yes.
All right, very good. So this draft, and Warren can feel the pain as well, but we've been working on this for a long, long time. And we received a daunting amount of comments, discusses during IESJ review, and we've been slowly picking away at them. At first, we just kind of just ignored them because we had a lot more better things to do, and we were just kind of over the draft. But we are slowly picking away at them. If you go to the next slide. You'll see the document history in just the last few months anyway. And so what we've done is, so Alyssa is the first one who made quite a list of comments. And just in total, it's just a lot of work, just editing and adding explanations of different things. And so we submitted a new draft after her comments, and her discuss was then cleared. We did the same with Roman's comments and submitted a new draft, which is the one we have now. He cleared his discuss, and so what we have now is one remaining discuss on the next slide. I think it shows. No, we'll get to that one, but
Which okay, slide 1, 2, 3.
just stay on 3 then. That's perfect. Yeah, this just gives you an example of some of the editing that was needed, because with all the comments, people say, why is it taking you so long? Well, there's just a lot of comments like that just take time to address, and recreating paragraphs. And one of them was, it appears that you're recommend using ARP sponge. And so providing some general caution about ARP poisoning and false advertising. And so then we just recreated that and gave an explanation about it, and had to look up ARP sponge and all that and try to make a reasonable discussion about it. And then just on and on it goes. So this is what we're doing, and the process is slow, but it is working. And I would anticipate that we will be done, and really done with this draft by next IETF, assuming that the remaining discusses are addressed. If you go to the next slide, okay. So Benjamin's, these are the remaining, he's the last one who made a list of comments, and there's pages of them. And so we will address those and submit a new draft in the next few weeks. And then if he clears them, which he probably will, then we hopefully are done. There are several other people who made comments during the review, but yeah, if you go to the last slide, but we should be good to publish once that last discuss is cleared. So it is a good, I'm biased, but it is a good document that just discusses issues in multicast in a Wi-Fi environment. And there have been comments to add additional things to it, because there's always some good points, and we've added a lot of them, but now we're not adding anything else to it. We're just trying to finish it up and be done. Any questions about any of that?
All right. Mike, moving right along, do you want to do the telemetry? Are you
Sure.
starting with that?
Yeah, I don't see any of my other co-authors online, so it's me, it appears.
All right, let's bring that one up. Hold on a sec here. Let's see, screen will be. This one. No, not that. Heck, how about this one? Okay, maybe this will work better. Mike, while I'm furiously clicking around here, why don't you begin to start talking about this draft?
Yeah.
I'll get there.
Sure. Yeah, there's not a ton to be said about it. Anyway, I do see how you on the line as well. So one of my co-authors is here. We're sharing in the morning pain with all of you. Thank you, how you. So chime in if there's anything you want to add. But so this draft was recently adopted by a MBONED working group. It's we added a few authors as well who are very interested in working on this topic and anxious to contribute. We do highlight a variety of telemetry solutions in the draft and describe the problem. I think probably what we'll do is there is a fair amount of interest in, increasingly interest, which is good, in OAM related topics. So we'll probably make that more robust in the document, just kind of describing that better. If it gets too big, we'll propose spinning it off into its own OAM draft, perhaps, in just more of a multicast OAM type of a draft. But I am looking forward to working on this draft because it is a good topic. If you go to the next slide, we'll probably just fly through some of these slides. So this is
can you see this
just
slide
kind of
clearly, or is it?
Go ahead.
It looks a little.
Clear enough, but it does.
Is there some artifacts on it?
Little squares in the upper right hand side, but it's fine. I can see all the words in it. Yeah, there you go. Moving it around helps a little bit. Keep doing whatever you got to do. That's fine to try to make it look good for future presentations. But so multicast traffic monitoring is important, just like as it is with unicast. It's important to reconstruct and visualize that multicast tree for performance monitoring and troubleshooting. And there are some techniques that can be used for multicast, and that's those techniques for unicast are being developed in IPPN working group. It was agreed to work on the multicast pieces here. They do have flaws for multicast, the current on-path techniques, and so there are some solutions that are discussed. There may be some new ones that we'll perhaps introduce to the draft as well to get some idea. But the goal is to allow the original multicast tree to be correctly reconstructed without unnecessary replication of the telemetry information. Next slide. So there are a couple different solutions that we have. There's a per hop postcard and a per section postcard, which are both enhancements. The per hop postcard is a branch node replicates the packets, and each branch node adds a branch identifier to the instruction header. Go to the next slide. So per section postcard, it's a postcard and that's what it's called in the IPPM working group. A postcard is sent at each section's end node, and the postcard contains data for the entire section. And those postcards can be easily stitched together. There's no need to modify the existing IOAM header format. Next slide. So as I mentioned at the beginning, perhaps we will add more of an OAM overview at the start. We'll develop the sections. And I'm seeing a variety of things here, but I think that's basically the point we wanted to make. Is that anything else you wanted to add, to what we plan to do in the future for this draft? I suppose not. So, yeah, any questions? Just kind of as a general comment, and Lenny and I kind of swap some emails back and forth, but there are some newer applications for multicast that are, in my opinion, making multicast more and more relevant, including live streaming, which has taken off. And it's not all about sports anymore, and it's even live sports. And so I think of these OAM related techniques, as multicast is projected to take more and more of network bandwidth, will become even more important. And in fact, as a side note, it may be helpful for MBONED to have maybe a new draft that kind of talks about some of those new relevant techniques that's using multicast.
Jake, I see you in the queue. Jake, you're free to speak.
Sorry. Can you hear me?
Yes.
All right, good. So yeah, just a quick question about is there, I skimmed the draft, but there was some detail. Like, are you addressing the sort of scalability issues of the analysis of the OAM telemetry across a multicast network, or as part of the draft, or is that sort of left to the apps?
That's left to the apps.
I see.
Yeah, we're addressing the efficient sending of telemetry data to wherever you want that to be sent.
Okay.
That.
Okay. So there's not like recommendations you think need to go in there? That's like already sort of reasonably well covered by the apps, or?
Yeah, that's a great point. Maybe we probably should add, because I'm not even familiar with some of those apps, so that would be a good thing to look into.
All right. Yeah, just wondering. It seems kind of maybe useful in theory. I'm not quite sure what to. Yeah. All right. Thanks.
Well, we'll find.
Just curious.
We'll find out. Good comment. Yeah, if we'll put something in the draft, I think that's good. Thanks.
Great, thanks, Mick. And just a little bit background, I forgot to mention. This draft was adopted. So this was presented in 109 in both MBONED and PIM. It previously had been adopted or had been presented in IPPM. And there was, I think Mike, you started at IPPM. They were busy, not interested, and then presented in PIM and MBONED last time. And it was decided that MBONED, with the operational aspects of this draft, seemed like a better fit. So that's how we ended up with it, and it was adopted with fairly strong consensus. So moving right along. I believe, who's up next? Jake, are you next? Oriel is up. So.
Oh, good morning or good afternoon.
Hold on one second, Oriel, while I bring up your slides here.
I'm located in Europe, so I'm fully awake by this time.
Yeah. A little less so here in the US. It could explain my challenges in clicking things here.
No West Coast sympathy for you East Coasters.
Yeah. All right. And we are coming over here. Here we go. Okay.
So, hello, everybody. My name is Oriol Español, and I work as a UMEDcast system engineer for UMEDSAT. I'm actually very excited to be here today and share some details of our services with you. Just as a background short story, why we're here today. Apparently, and I didn't know this before, UMEDSAT is one of the top 3 contributors of multicast traffic on the MBONE with our UMEDcast terrestrial service. I understand that some of you thought it would be interesting to know more about our case. So Leonard made this possible thanks to a common contact that we have in Jen. So thank you, Leonard, for making this possible. Okay, next slide. So the plan is we have a short presentation on who we are and what we do. Quick system overview on our satellite and terrestrial services, follow up by the details about the terrestrial service, which I presume is the most interesting part to you. I have around 15 slides in total to present, but feel free to ask me any questions during the presentation if something's not clear or you want more details about that. So next slide, please. So who we are and what we do. UMEDSAT stands for European Organization for the Exploitation of Meteorological Satellites, and we are a public sector organization with currently 30 funding European member states. Our mission is to maintain and exploit the European meteorological satellites. That means that UMEDSAT is responsible for the launch and operation of the satellites, and especially relevant for us today, delivering satellite data to the end users. The end users use this data for weather prediction and global monitoring of climate change. Climate change and weather prediction is a common global interest, and UMEDSAT has established cooperation with partners from other countries such as China, India, Japan, Russia, South Korea, and the United States. Typically, this collaboration includes some sort of exchange of data. Our users are meteorological services of our member states, research institutions, universities, but also private users and commercial users. And of course, our bilateral partners from the countries mentioned before. Our users are mainly located in Europe, and that is basically inside the footprint of our satellite service, but also more and more around the world. And we reach these users thanks to our terrestrial service. So next slide, please. These slides present a system overview of the UMEDcast, which is UMEDSAT's push service that delivers environmental data in near real time to its registered users. The data delivery is implemented as an IP multicast one-to-many dissemination system with a single transmission from the server and guaranteed timeliness distribution to the end users' reception stations. Therefore, it allows the end users to receive the data on their reception station shortly after UMEDSAT makes it available. On the left side, you see the data acquisition process directly from the satellites operated by UMEDSAT and into the ground station and into UMEDSAT headquarters in Darmstadt, Germany. From there, it's sent out via IP multicast to our satellite and terrestrial services. On the top side, this is the UMETcast satellite service. For this service, the multicast is transferred via a dedicated link from UMETSAT to the uplink facility. There, the multicast is encoded into a DVB signal and transmitted to geostationary communication satellites for broadcast to user reception stations. Each reception station decodes the signal and recreates the original multicast stream. In the middle, you see UMETcast Terrestrial over GN. This is an evolution of the UMETcast satellite system. However, instead of using commercial satellites for dissemination to the users, the terrestrial service relies on the network infrastructure provided by GN across Europe. The service relies on native multicast. However, in order to overcome islands of non-multicast enabled networks, GN also provides the option to use GRE tunnels directly to the reception stations of the end users. These are manually activated on demand when a temporal loss of multicast is detected. At the bottom, you see UMETcast Terrestrial over Internet service. This is a further evolution of the terrestrial system. However, instead of using the GN network, this service relies on the Internet. Commercial service provider operates the L2TP IPsec tunnels for us, which encapsulates the multicast traffic from UMETSAT and sends it to the end user station. One added benefit of this setup is that it's not traversal without requiring a reconfiguration of the end user's firewalls. A key takeaway from this slide is that we have only one source of multicast traffic. We have, however, different group addresses for the satellite and terrestrial service. The motivation for this is that these groups require different reliability configuration, so we prefer to split them. However, this being multicast, we could have the same groups for the satellite and terrestrial services as well. Next slide, please. So again, this slide presents the segregation of the two terrestrial streams and the motivation why this is needed. On one side, we have the native multicast service provided by GN. This is the most cost-effective solution and it's the default and preferred transport layer. Then on top of that, GN also provides these on-demand GRE tunnels to overcome these islands of non-enabled multicast. And typically, when the user is connected to an NREN that does not support native multicast, however, we run into what we call the eligibility problems. That is that the user is not eligible to connect to the NREN, maybe because the users do not belong to a research institution. For instance, it could be a commercial or radio. And second, UMETSAT data might not be eligible to circulate in the NREN because the NREN considers this data of non-research nature. Because UMETSAT needs to guarantee access to its data to all national member states. The internet leg of the UMETcast terrestrial services was developed, which then uses this L2TP IPsec encapsulation to deliver the multicast traffic, because as we know, the internet is not multicast capable. Yeah, so next slide, please. So how is UMETcast, how is this UMETcast service implemented? So UMETcast is a near real-time dissemination system based in IP multicast push with guaranteed timeliness delivery. We distribute our data as files, and they have like a short expiration date, so to speak. That means that all data not distributed within timeliness is not that interesting for the users anymore. We do not distribute any video. It's just files, plain files with satellite data. This multicast system is based in telecast server and client software packages, which are provided by ST Engineering, by a private company. This software is distributed as commercial off the shelf. It has been implemented following the MTP SO standard, which is based in an IETF internet draft from November 1997. Because of this underlying multicast technology, our output stream is highly scalable with a number of users and volumes of data. and it provides EUMETSAT with a secure way to deliver data to its users. We can target data delivery to specific users or groups of users. Moreover, we can do that ensuring that our data policy is respected. We can handle any file format and size, so we can disseminate a broad range of products. The terrestrial service is considered now complementary and backup service to the main satellite dissemination system, which has a guaranteed SLA. Next slide, please. The telecast, this software delivers the multicast as single source multicast, and the joint messages are via IGMP v3. As such, the sender does not necessarily need to be aware of who these receivers are and how many there are. However, Telecast implements 3 different and complementary reliability mechanisms, and for 2 of those, the recipients need to communicate with the sender. So these 3 reliability mechanisms are FEC, forward error correction, NAC, negative acknowledgement, and ACK acknowledgement. So first, the FEC is this is performed on the fly and does not trigger retransmission. On our operational platform, this is currently configured at 10% of FEC. Then we have second the NACs, which are generated when a client detects lost packets. In that case, a negative acknowledgement is sent upstream to the source, which retransmits the lost packets via multicast to all subscribed recipients. The NACs are sent back to the source using unicast UDP. Then we have the ACKs, which are generated after the file transmission is over. Then those recipients that still have lost packets from the nominal transmission and the NACs report their status to the server, which then initiates a new multicast transmission that includes all the missing packets reported by all the recipients. Only those recipients that have incomplete files listen to this new transmission. Together, the NACs and the ACKs are what we call the feedback channel. Then going back to the notion of timeliness, I would like to note that the NACs trigger immediate retransmissions and do not significantly impact the overall timeliness of the delivered files. On the other hand, the retransmissions triggered by the ACK messages introduce a delay on the file delivery and also produce files delivered to the end user out of order. So what can we recover from these lost packets with these reliability mechanisms? So our testing shows that random packet loss below 5% is fully recovered by FEC alone without any retransmissions. That interruptions of less than 400 milliseconds are fully recovered by FEC alone without retransmissions. That interruptions of less than 1-2 seconds are fully recovered by NAC and FEC working together. And interruptions of more than 2 seconds can be recovered by ACK, but they introduce a delay in the file delivery. Now, with the with the increase of number of recipients, we can have the case where one or several recipients with low quality links impact the nominal transmission to the rest of the participants. This is what we call the crying baby. And that is a user constantly asking for retransmissions. And in order to prevent that from impacting all users, the telecast software has several countermeasures in place for each of those mechanisms. For instance, for the NAC, there is a configurable maximum bandwidth, a percentage of the total available bandwidth that can be used for retransmissions. So the nominal transmission is always guaranteed. This is currently set at 50% for our operational settings. For then for the AX, there is a configurable minimum that the recipient must have received of the send file in order to trigger a retransmission. This is currently set at 40% in our operational platform. That means that end users that receive less of 40% of the file are discarded for retransmissions. These settings are based on trial and error tuning on the platform. Yeah. So some more additional relevant settings of our operational implementation is this time to live that is currently set at 64, and the MTU size at 1400. So that is below the 1500, so that the same multicast stream that the same native multicast stream that we send out can be encapsulated into the GRE tunnels as well. So it's the same stream. Okay. Yeah. Next slide, please.
Just a quick question, Oriol. Did you develop this internally in-house or using off the shelf or some other type of open source?
Okay. Yeah. No, good question. So this is commercial off the shelf. This is COTS, and it's kind of old, it's an old implementation. Maybe it's from 10, 15 years ago. But it's still being used operationally by the company that produced this initially, and they use it mainly for satellite communications. They don't offer it anymore to businesses. However, they still use it for their own operations. So we are one of their last users that do not rely on their actual hardware. That we use this software just standing alone with no hardware, without their hardware.
Right.
Okay. Yeah. Thanks. So Giant acts as the sole network, as a network service provider, an interface point for us with the rest of the national research and educational networks. And Gian provides the backbone network topology for the European region, but also collaborates with other pan-European NREMs to provide global connectivity to their users. Therefore, we rely on Gian to grant us access to end users worldwide. Yeah, and this is what this map shows. All the connections that Gian gives us, especially relevant for your case, probably with the internet too. Okay. Next slide, please. So these slides present colored in dark blue all the countries where there are Webrtc terrestrial stations operating and receiving our traffic, so that you see that the terrestrial service provides access to users outside the Webrtc, outside the satellite footprint, which is over Europe mainly. And especially relevant to the MBONE working group is probably the University of Wisconsin-Madison, because thanks to this user, the native multicast flows through the internet too and the MBONE. There is another user in the USA that receives our traffic. This is Noah Star. However, they receive it via GRE tunnel, and the reason for that is that some institutional users do not like multicast traffic flowing into their system, so they prefer the good old known TCP/IP. All right, next slide, please. Okay, so this is an example on how we calculate the availability of the service for each individual user of the terrestrial service. In particular, this corresponds to last February. This is what we call end-to-end file-based monitoring. Basically, we compare for each station what files it should have received against the actual files it received, and then we compute the percentage. So the color coding has been inherited from the SLA that we have for the satellite service, where file availability below 99.5% is not acceptable. So these computations are based on the ACK packets from the feedback channel. And in our experience, the common reasons for achieving lower availability are network bottlenecks and congestion. Some countries have very good links, like within Europe to Japan or the US. However, in other countries, the networks are not so good. Also due to insufficient last mile bandwidth. And this is typically the end user subscribing to more data than they can actually receive. Then related to the previous point, we have observed that TCP/IP traffic tends to push out multicast traffic on links where bandwidth is scarce. And firewall updates also combined with troubleshooting difficulties also lead to lower availability measured. All right. Next slide, please.
And Oriol, the feedback channel, is that unicast or is that multicast?
That is unicast, TCP/IP unicast.
Is there any issues with scale in terms of if you had, zillions and zillions of receivers? Would that be a challenge? Or
So we have two feedback channels. We have the negative acknowledgement, which is UDP, unicast UDP, and then we have the acknowledgement, which is TCP/IP unicast. The NAC is more scalable. However, you can still have like a NAC implosion if you like. But we have measures in place to, I think if you go to a previous slide, we have measures in place to prevent that from impacting the other users. That is this one. That is, so you see these three methods, the NAC and the ACK. So the return channel, UDP unicast or TCP/IP unicast. For the NAC, we have a limit of 50%. That is from the available bandwidth that we have, 50% must be nominal multicast, and the other 50% can be used to address retransmissions. So we are always sure that the end users that have a good link will be able to receive, will not be impacted by end users that have a low quality link and that are generating a lot of negative acknowledgements. But at the numbers that we're managing at the moment, we obviously they are still small, so we don't see that as of an issue for the moment.
Great.
I think we were slide 12. Yeah, that one. So satellite industry has very long cycles, so we can predict fairly well what our bandwidth needs will be in the future. This slide presents the future bandwidth needs for satellite and terrestrial. For terrestrial, you see it goes from the current 400 megabits to a peak of almost 1 gigabit per second by the end of 2025. Then it stagnates around 800 megabits. The steep increase between years 2023, 24, and 25 are due to introducing new missions and new satellites. The satellite bandwidth needs are lower. Motivation is that the satellite capacity is much more expensive than the terrestrial bandwidth, and that is by an order of magnitude. Therefore, EUMETSAT has strategically decided to send via satellite only what we call essential data. That is the data needed for most of our users, and that corresponds to the data from the geostationary satellites. On the other hand, the terrestrial service has all data from EUMETSAT. All right, so next slide, please. Thank you. So we are currently analyzing the use of AMT to complement our terrestrial service. For instance, I see the potential of this technology to provide access to our data to private and commercial users that have no access to the entrance. We are still at the very early stage. We have done some testing with the AMT gateway implementation from this link from GitHub. I understand Mike Holland is one of the main contributors of this software. So many thanks for that. Really appreciate it. Basically, it worked out of the box for us. We created a simple 13-line script to set up the interface and connect it to the AMT relay source of M2 ICAST. After that, the telecast client was ready to receive the complete terrestrial stream via Internet 2, the Internet 2 relays in USA. And we had very good results. This is based in a 400 megabits per second internet connection in Germany. So basically, the data was going from Darmstadt via Multicast to Internet 2, and then via the relay back to Germany. And we did several tests. So when no feedback channel and with a bandwidth of around 100 megabit stream, 0.6 packets, 0.6 percent of the packets were lost even after the fact. However, that has a dramatic impact in the number of lost files. Because if we lose just a few bytes of one of the files and we are not able to recover them, then the file is considered corrupted and discarded. Therefore, just a few lost packets have a very big impact. So, however, the results look very different when the negative acknowledgement channel is enabled. Then for 90 megabits per second bandwidth, and for a period of 2 hours that we did our testing, there were no lost packets at all, and 100% of the files were received. So these are very, 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 very good results. We also tested reception at full stream of 300 megabits per second, and it was possible. However, we just stopped the test immediately. We just did it for a few minutes and then stopped, just to not cause any problems to anybody. Yeah. So next slide, please.
Sure. And
Here.
by the way, for those interested,
yeah.
that's Jake was the owner of this GitHub repo, Jake Holland. And there's a question from Stig about, is this service freely available to private end users with AMT without the feedback channel? Or was this just testing that you tried out once?
This was was testing. It obviously it is available to private users via AMT. Yes, it is. However, we still do not support that operationally, meaning that a user can implement that on their own, but we cannot guarantee the service. And as we do for the other implementations via native multicast, via GN, and so on. And at the moment we're working together with GN to see if we can enable the AMT gateways on the and on the border routers of the network, because they also have Juniper equipment, so they could potentially enable that if they see. But first we're working with them to see if this can have some effect on their network or not. So we're still in the lab, working on the lab, if you like. Okay. So this
just time check, five minutes, Oriol.
Sorry, I'm almost over. Yes. Okay, so this is so we run this AMT on Ubuntu distro, and you see this is just capture of the traffic received. So next slide, please. And this is the last one. Basically a recap of the key takeaways. So we have one-to-many distribution, one single source, which is highly scalable with a number of users and data. Our cost model shows that solution is cost effective for above 10 users. We have at the moment 4,000 users of the UMedCast satellite service. So in the future, we might be migrating many of those users from satellite to terrestrial. High availability, yes, but only if protocol reliability is implemented. Yeah, if this feedback channel is enabled. Word coverage versus satellite footprint only, and we can handle any type of file format and size. Yeah. However, I must say, so obviously for this to work, it requires a multicast enabled network infrastructure, and we know internet is not yet multicast ready. It requires expertise in network setup. It's not straightforward for somebody who has not much experience with this. And there is also some end user resistance to enable native multicast on their network. And as already mentioned, there is a risk of cross impact. That is, if this is not properly handled, the users with bad quality links can impact the availability and timeliness of nominal transmission. And yes, and next slide, which is just questions and answers.
I have a question. Do you use any kind of access control, encryption, anything like that?
Yeah. So that's a very good question. So we need to have a strong authentication and encryption for various reasons. First, to enforce the data policy. That is, only those users registered and allowed to receive our data can actually do so. Then there is also the what we call data denial service for certain substreams. For instance, all the for some instruments. That is when certain data need to be made available only to a subset of users. For instance, in case of conflict or war. And yes, we do have authentication and encryption. This is based on USB token in combination with username and password. So this is a two key factor system. We distribute these USB tokens to the end users, and they can only unencrypt our data if the EKU is plugged in and configured. So basically, we have two types of streams, if you like. So first stream is what we call the announcement channel. This is unencrypted, and that means that any user can listen to this channel. This channel, however, contains all the information on the data channels, at what time they start, what files they contain, and so on and so forth. And then these data channels themselves are encrypted, and only users with a functioning EKU can unencrypt that data.
Jake?
Yeah, follow up on that. Or this is Jake.
Hello.
Is that like once the file is completely downloaded, then you can only unencrypt it when you're holding the if you have the right key, or is that sort of like as you're going, you're able to get the bits and pieces?
That's correct. So first, the file is completely downloaded, and then it checks for the existence of this EKU, of this dongle, and then if that is granted, then the file is unencrypted.
Great, thank you.
Oriel, can you?
Yeah, and
I'm sorry.
That great presentation.
Tim?
Yeah, thanks. I just wanted to ask, you've mentioned obviously with Joan from the NRENs, you can run natively. the end sites, or it can be tunneled. Is the case for tunneling usually that the end site does not support multicast rather than the NRENs and JARP? Because I think most NRENs and JARP support multicast natively, just like they support V6 natively, for example. So is it usually the end site rather than the NRENs, just for clarity?
Typically is the NRENs.
Really? Okay.
Yes, but however, I must say that Gian is doing an excellent work on that. So whenever we detect that, or we have an end user located on an NREN that is not multicast enabled, then they do their best to support them and help them enable it. And eventually it takes some time. So we use these GRE tunnels to bridge the gap. That might take from a few weeks to a few months until that NREN then starts supporting multicast natively. So it's yeah.
Okay. Yeah, I mean, I believe in the UK example with the ECMWF and
Yes.
the Met Office, that it's those sites that don't have multicast that means it needs to be tunneled, whereas the UK NREN Janet does support multicast. I just wondered whether that was common across Europe or not.
Mm-hmm. It varies from country to country. That's why we have like a portfolio of services, because our mission is to make the.
You want to get the content there, don't you? You're not,
exactly. We need to get the content.
or tunneled. You just want to make sure the capability is there.
Exactly. However, we always try to we encourage the users to use native multicast, because we understand that, for instance, once that is enabled in a country, for instance, the case of, I don't know, any new countries that doesn't have native multicast, we have one user there. And once native multicast is supported, then it doesn't matter how many users we have there, yeah? And it will be just a plug and play, if you like. So it's the first one that takes a bit longer.
Right, thanks. Yeah, I'm involved with the JARP project and the UK. And I've sent you a message with my email address if you want to follow up. I'll be very happy.
Okay, thank you. Oh, yes, I see it now. Thank you.
Right. Thank you.
Jake?
Yeah, the approximately how many end users do you have, if you can share that?
Yes. So UMedCast Satellite, this is the first service that we started with multicast. It started like 15 years ago, and we have at the moment 4,500 users. Then for the terrestrial service, native multicast, we have around 25 users. And with a combination of all the rest of GRE tunnels and L2TP IPsec, we have 10 more users. However, we're in kind of a transition phase where we know that most of our data in the future will only be available through the terrestrial links, and mainly through the native multicast. So we are encouraging now our users to start migrating or setting up their stations via the terrestrial links, via native multicast.
Okay, thank you.
And Oriol, what about CDN? What about you doing this plain old unicast? How much is multicast, would you say? Can you articulate, how much more efficient the efficiency gains you get from multicast over, say, just doing unicast or CDNs?
Okay. Yeah. Our data is it's very dynamic. We only send the data file once, and after a certain period of time, it has expired. It has no more value to our users. Therefore, the concept with the CDN, I don't see it really applicable to our case, because I understand that it makes sense for the CDNs, for this data replication to stay on those hubs for longer periods of time, like if you like Netflix, for instance. But for our case, I don't see it. And besides, the cost of multicast, native multicast over terrestrial link is so low compared to the alternatives that I think that from the cost perspective, I don't think it will make sense either. That's my so maybe I can share a little more on the cost. side. So we have done some evaluations internally, and we see, obviously I'm stating something that you know already, that the cost of native multicast is the fixed cost, regardless of how many users you have. We see that already for UMIDcast satellite. However, the bandwidth, the satellite capacity is very expensive. That's why we're migrating to similar concept of disseminating via multicast, but over the terrestrial links, which it has this fixed cost regardless of the number of users, and it's around one order of magnitude less. So it's quite cost efficient. Yeah.
Great.
Yes.
Well, we have to move on to our next prezo, but this was great. I think you're putting together pretty much every bit of multicast between access control, encryption, reliability, and interdomain SSM. It's great to see AMT. It's great to see a lot of the tools developed here in action.
Yeah, actually, this AMT technology, it looks very, very promising for our case, and we are looking forward to test that more extensively. So maybe I'll get back to some of you for some support at some point. I'll, if you don't mind, I'll share also my contacts in the chat, and you can please contact me if you have any further questions.
Great, thank you.
Thank you.
All right, Jake.
Well, that was very cool, and good to hear you're getting 100 megabits out of the AMT. Yeah, I don't think I've run it that fast yet. And it wasn't just me, by the way. I think I put it up in its current sort of location and cleaned it up a bit, but this was this working group actually did the bulk of the work, and I just sort of got it running again. So and that was all before my time. So yeah. Right, I think I will, by my count, we are about 17 minutes behind, I think. And so I'm going to try and be really fast because I really want to hear Lorenzo's presentation.
Yeah, so Jake, you have till, can you take it to the bottom of the hour, 5:30 your time? 23 minutes?
I will try to be done by then, yeah. All right, so yeah, I'm Jake. I'm working on these 4 drafts. Mostly what I'm really working on is trying to make the deployment more plausible. And these drafts are more like a step that helps me do that. But I do want them to happen. So yeah, next slide, please. Did I get you the outline in time? Is it there? No. Okay, so I sent some updated slides. They had an outline. I think there's 4 things. I'm going to cover the trial status, the brief overview of the benefits we're seeing in our benefit analysis modeling, the status of the implementations we have ongoing, and the updates on the docs and their sort of current status and the next steps we're looking at. So the first thing is the trial status. So we've hooked up with 6 ISPs that are working with our ingest platform. That includes the AMT gateway and the Dryad-based sort of lookup to drive it, based on a receive. I presented about that before, so I'm not going to go over it now. The traffic we're running, we have a couple different pieces. There's so we've got some of our own test traffic, but we also have some production traffic from several different content providers that are I think they're customers of ours, I assume, and they're geolocated with the relevant ISPs to sort of prove out the notion of distributing some of the local content with multicast ingested sort of in the over the top method into the ISPs and then distributed within the ISPs. Virgin Media, shout out to Loba, Neil, and Harry. Thanks for the feedback. The other partners we've got have not yet given permission to use their names, so we're respecting that. Most of the trials are still active, and people are still messing with the setup. So a few of them have not yet started. So the 6 only refers to the ones that we've got actually some level of work has actually begun in those ISPs. There are more on the way, and more are welcome. We're actually looking at trying to sort of make the trial artifacts more public and let people stand it up and try things on their own as our next step. So next slide, please.
And Jake, did you say you had newer slides? Sorry, I might have missed those.
It was just one thing with the outline. I sent it like 10 minutes before we started, right. So sorry, my bad. And just realizing I had left out the outline. So there's a few key insights we've gotten from the trials. One is that consistently some of the feedback we're getting from the ISPs, and this includes not just the ones that have participated in the trials, but some that we've talked to that have not participated yet, or that don't that don't believe us yet. The game downloads are a big part of why they're interested. Right now, this is one of the key pain points that people are experiencing. So it's not just about delivering video and real-time stuff. It's also about just getting a better job done on the peak offloads. Another is that MNAT. Maybe I shouldn't say MNAT, but rather the problems that MNAT can work around were more prevalent than we expected. Of the 6 that have started, one of them has proven it out without needing any MNAT. 2 of them we didn't think we were going to need MNAT, but it turned out we did, and it was a good thing that we had a build sort of almost running by then. And the 4th one, we knew from the front that we were going to need MNAT. And then there's 2 that we haven't yet gotten them working yet, so we aren't totally sure yet whether it's going to be necessary or not. But this was, I mean, it's a small sample size, but it's relatively high. Like some of the issues encountered, I think there might be one more I need to add to the motivation section of the MNAT draft, but mostly they're in line with the things we've seen there. It was basically like their TV service was only using ASM, and so their home gateways did support multicast, but only IGMP-v2. And although they think they can upgrade that with the firmware at some point, and they do sort of manage the home gateways, that's a whole update cycle that's going to take a while, and they were able to proceed by using MNAT all the way south of the home gateway with the egress. So we're looking into, I'll get to that in the browser update. But the overall answer is that it's looking like cautious optimism is about the right way to look at this. We haven't hit any stoppers yet. And we're thinking that this is going to be plausible and pretty good based on the sort of feedback that we're getting. So yeah, good. It is pretty slow right now. The implementations are a bit crappy of the prototype stuff. So that might impact the drafts also. So yeah, next slide. And I think we're into the benefit analysis. I'll be real quick on this. So this is a work in progress, and I just wanted to give a quick preview. But the basic idea is there's a bunch of the traffic that we're actually sending according to our logs and our stats of whatever. So this is a snapshot of like one ISP on one normal day. So nothing special here. There's a bunch of the traffic that we haven't managed to pin down, like how would we multicast it or not, and it's less that we think it's not multicastable than that there's details of doing the log analysis that we haven't got to yet. So although we think that some of it will remain as probably not multicastable in a broader sense, it's not quite as big as what that blue represents. But the green part is the part that we have analyzed, and the dark green part is the part we think we can chop off based on what we've got. So if you go to the next slide, that digs into the green bit there. And we're from this part with conservative estimates, we're seeing about we think that an 8% of the total traffic into the ISP is a lower bound on what we think we can offload, and we think it's going to get better as we go forward. So this is part of why we think it's as we get sort of more of this analysis done. So this is part of why we think it's going to be feasible here, and we're seeing a sort of long tail effect where you know these colors here are different levels, and they're in the top left of the chart there. It's like that first block is if you just had one object that was being multicasted, then that's how much you'd be able to offload of the traffic. If you take the top object that we think we can. If you take another 5 objects, then that's the next block. And then it goes to 10 and then 20 and 50. You can see there's sort of a diminishing return. But again, those numbers should get somewhat bigger when we get access to more objects in there. So this is the sort of direction we're going with how we're looking at the analysis and what we're hoping to achieve. And it's mostly about shaving off the peak is the big driver for the ISP. So that's where we're looking to sort of capture the most value on that side of it. And this is also an important consideration on our side, although we're not sure that this style of modeling really captures the whole thing, because it's based only on what we're actually doing today, not covering necessarily all the potential improvements as we shift more things to be able to use this. So so looking at this as a lower bound on what we think we can achieve is it's a good start, but there's a lot more to do on this, so don't take it as any kind of final. Yeah, next slide, unless there's any.
Hang on, Jake, I had a question for the slide.
Yeah.
That's correct. This is Greg. Can we go back to the previous slide? So I can talk when it comes up. There we go. Is this based on just download traffic, or you're looking at your entire traffic profile that could be offloaded?
So the blue chart in the one before that is based on the entire traffic profile of everything we sent into the ISP.
Okay.
Grand total, and which is and that only counts download. I mean, there might be some amount of traffic that is involved in receiving some upload something, but
no, but I mean specifically file download, like game updates and stuff like that, not necessarily live content of any kind.
Oh, this part, I think, so on some of the analyses we've done, we're trying to get to where we merge them, and it's not quite done yet. I think this one covers mostly things that we think would be achievable game downloads. I'm not sure whether we got any live content in this one or not. The live ones are more interesting so far. We've seen on the big peak days with a popular sporting event, right. And so yeah. That is not one of these days, and that's not part of this analysis. This is more like just this is like a normal Tuesday where there's some game downloads or something.
That was my next question. This was just like a typical day, as opposed to like some Mother's Day event where you get hammered.
Right. Now the Mother's Day events, we know it's going to be a lot bigger. And again, this analysis is not quite complete. Actually, our cluster's having trouble, which is why I don't have more of these charts. But yeah, the next one I'm hoping will have some more interesting numbers. Excellent. I just wanted to give a quick snapshot of what we've got here, and showed that even a very sort of pessimistic view of this is it's hard to say that it's not going to be profitable. So we really do want to look into how to make that happen. Yeah, next slide, please. Right, so the Chromium Upstream is currently stalled and kind of in negotiations. We're trying to get through process hurdles and kind of get the security review we need to be able to check the early stuff in so that we don't have to carry the fork. That kind of fell through, so we're going to plan to carry a fork until we can sort it out, and we'll be releasing, or at least building regular updates. I think we'll be releasing them That's the intent, to just put up a binary that we'd built automatically with the regular dev updates plus one from the stable, I think. And that's so that's ongoing. We'll try to get it sorted out. We would still like to get into Chromium. If we had more public web developer support, that would be helpful. So if you know anybody who wants this stuff as a web API, then get them to speak up. I was able to cite several people who had contributed such statements, so thanks to those. That included Morten Peterson's comment about it, Guyan Mishra's comment about the way Verizon's using stuff, and the BBC's hackathon from some time ago, where they did a multicast video to the browser demo, but it required using WebSocket's unicast to a local gateway that actually did the multicast receive, which I assume that they would have preferred to have a browser API. So the other thing is that we think AMBI is more important to the end user, particularly the browser. AMBI being the authentication spec that is that's in the asymmetric authentication. Right, yes. But we think we're going to put the MNAT egress behavior into the browser API before we'll get the AMBI in there, because it's the way we're doing it now for the MNAT egress is sort of emulating an operating system embedded version of the egress, so that you don't have to have a separate box south of the home gateway where some of the problems are. So it's like running in the receiver as an external thing, and that thing is kind of a problem. So if it's embedded in the browser API, then it should be able to receive the natted version of the traffic, authenticate it as though it was global, and pass it to the web API that only ever had to know about the global stuff. So that's what we're trying to put in first. It's also easier to do and can help us with some of the prerequisites that we're going to need for AMBI as well. So yeah, next slide, please. The MNAT implementation, it's running. It's not great. It's polling right now, and we might have to look at this. Also applies to dorms. We might have to look at updating the specs to support a long poll sort of path for receiving updates, because it's like the JetConf implementation for RESTConf doesn't have the push easily built in. I'm not sure if we can make it happen, and so I'm looking into how to do that. But that'll be ongoing. The slowness is because it's doing like a 10-second poll, and we're going to have to do a little better than that. Well, we might have to do a little better than that. Like for our purposes, this is actually kind of okay, because we run with unicast for a while, and then like once the multicast starts working, we just start using it. But I'm not sure that'll really be okay for everybody that wants to do multicast development in the web browser. Anyway, MNAT is running in 3 of our trial partner labs, and using it. We've got IP6 support, but only so far for local SG assignments, not yet for global SGs. That's basically because one of our trial partners needed that, and we haven't needed it yet for the global SG, but we would like to get that in there too. Yeah, next slide, please. The ingest platform implementation, we cleaned up a bit and componentized some of the pieces. So I'd be happy to get into more details with anybody who wants to know more about that. But the ingest platform is sort of key to the making it easy for ISPs to perform the actual ingest of traffic from outside and redistribute it as native multicast inside. So yeah, but we also added a CBAC thing. I think I sent something in the list about it too. Anybody who wants to discuss it, I'd be very happy to get some discussion on the list. But yeah, I'll actually talk about the docs a little more here. So yeah, go ahead. Next slide. Right. So dorms and CBAC early review request sent. I'm hoping to get some good feedback there. I might. There was a couple updates to CBAC, and there's a couple updates we probably are going to want to make also. The priority concept, I'm not sure is really good. The way reconnecting audio. Can you guys hear me again?
Yes, I can hear you.
It said there was an error. Did I cut
You
out?
cut out for about
Yeah, you cut out for a
5
bit, but you're back
seconds.
now.
Okay. All right. So the right, dorms and CBAC early review. The CBAC I think needs a couple updates on the sort of circuit breaker behavior, and dorms. Actually, I don't think I put it on this slide, but I think I also need to make sure that the push update is going to be feasible somehow. And there's a chance that we'll need an update to the spec as well. So so I think we're going to do some experiments on that and see if I can get something working. But right now, it's anything that's using it is just polling. So I'm not sure how that'll be enough, especially with regard to speed of updates as we go forward. It could be done as a later rev, so if we need to, then I could get the doc pushed earlier than that. But yeah, I'm not sure it's quite good enough as it stands. It could use more review and engagement from people messing with it, feedback about it. But anyway, I'm working on these, but they've taken a backseat to the work with the ISPs and trying to get this deployable and maybe even deployed in places. So I feel like the progress has looked slow on these docs, but there's a lot of behind the scenes stuff happening. So yeah, next slide, please.
Jake, in terms of review, with 4 drafts, which would you say is, if people were to prioritize, which one should they, help with review? Which docs would you say are most important, or are they all equally equally important?
Yeah. So what I actually care the most about is whether it's really going to work. So what I'd love to see is more people experimenting with the actual implementation and seeing if there's and it's really like if there's parts of the implementation that won't be adequate for people, then that's where I'd like to see if there's things we can fix in the implementation, then great, fix them in the implementation. But if it requires a spec change, that's the part that I'm worried about. Like if we make this RFC and then it's like not quite good enough, then either we have to rev it, or like it makes it a little more noisy, I feel like, and less likely to succeed. So the biggest problems I see right now are the sort of slowness of the update of changes. And so I'm curious, like, how much do people care, and how bad is it, and like what sort of join time do you need to succeed? I'm not sure join time is the only consideration there, but it's probably one of the big ones. And then also things like CBAC, like how variable is your maximum bit rate, and can you like put a cap on the maximum bit rate and handle it? Like, is this actually going to work for other people who need to use it? These kinds of questions, I think, are where I have the most concerns right now. I'm making them work for me. That's great. You guys want to send it through, okay, but I'm not sure it will really meet my needs if it sort of gets adopted and turns into a spec, but more people don't use it than just me, right? So I think it needs to actually be usable for more people, not just like look usable, right? Right. So did that answer your question? I hope. And yes, 1 minute left. So next steps, I want to take the trials public, make it so that people can sort of self-serve and set it up and have all the pieces they need to run things, including the browser testing and a video stream to use it with. I'd like to and supporting people who are trying to do it. Maybe make a little community with a mailing list and a website or something. Anybody who wants to join me in trying to make that work, please reach out. I'd love to talk about it. I don't think this needs to be a sort of Akamai internal effort only. I also would like to try doing native delivery on I2, where they have I2 and also Giant. That like I2 is the only one I knew about, but if Giant is also doing native multicast, then yeah, let's get an ingest platform set up and running in there, and see if we can get the traffic delivered to those who can receive it natively. Other contacts, I think would also be great. Like, we're trying to sort of widen these trials, and I think any place that's willing to forward native multicast is a good candidate to talk about it with. I want to get the file delivery sort of better done. One idea I've got is to try extending APT, the Ubuntu package delivery system. Like, if we can make it so that that's sort of auto updating with the most popular downloads of packages, and they're available over multicast, and maybe trying to do it, that might be a really interesting path to sort of get some useful traffic that doesn't have to be gated on a company buying in. So I'm gonna see if I can do any looking into that, and see sort of what hurdles I run into. Like, right now, the like Raptor implementation, there's some distribution limits on it, so I need to sort of figure out what I can do to solve that. But I would like to make sure that the file download use case actually works, because that's one of the big drivers for the ISPs. And the other thing is to engage some big game delivery partners, because that also is we're talking to them, but we're not as far along as I'd like to be on that. And we either got to get into Chromium or start doing this work in a different browser. We had some interest in doing things in Rust from a couple of student researchers. So actually, I would love to end up doing it in both and in more browsers. But Chromium is sort of the more widely distributed one so far. So I was starting there, but I'm not too hung up on it. So if we can't get into the upstream on that, then we might want to look into somewhere else. But I'm still hopeful that we'll get into everywhere ultimately. Yeah, and I'd like to get dorms, but I want to make sure that push updates are feasible. I think dorms is the closest to done in terms of the spec, but CBAC is probably not too far behind, but I think needs a little more work on the circuit breaker behavior part. And my biggest concern on dorms is really just the push updates. So I think that's all I've got. Any questions? I'm sorry, I'm 2 minutes late.
Yeah, can I throw just a couple at you quick, Jake? You mentioned this in beer a bit about working with Webrtc or Webrtc, and I was wondering is the expectation that they would just be able to use the browser plugin, or do you think there's extra work?
So Webrtc being the congestion control strategy recommended by Flute. I'm not sure everybody's familiar with, right? So Webrtc is a different thing from Webrtc in that sense. Yeah. So the Flute spec requires the use of Webrtc, and it's only experimental, but it's required to implement part of Flute as written. And I'm not sure it's actually good enough. It's like kind of a weird waveform equation-based receiver-driven congestion control or something. And that doesn't match the actual pattern traffics of the actual traffic pattern of anybody who's sending multicast that I know of, including ourselves. This sort of idea that you can send at a rate and then have it decay, and then by decaying you're going to use your join delay to determine what the congestion rate is. I don't think it actually works, and nobody who's using multicast seems to be doing it. So I think it might need an update if it's to be a sort of fully RFC compliant thing, and that is in some sense important, because the Raptor IPR restrictions are tied to full RFC compliance. So yeah, I've been looking at that a little bit.
Second question was, are there any builds for browsers that support this that can run on like a big screen, stick or Roku?
I don't have one. I just have the Chromium. I have an old Chromium built for Mac. I would like to get that working too, and the deb for Ubuntu, or the binaries for any Linux, I think. Yeah, if you want, I'd be happy to give you the source. It's right there. I'd be happy to help you get it running.
All right.
If you have a target that you're interested in.
Sure. Thanks.
Great. And thanks, Jake. In terms of your, question about Gian and other multicast-enabled networks, I bet that Tim Chown would probably be the expert in this group on
Yes.
the RENs, and he could probably direct you. I'll volunteer him as probably be the one who could give you the best guidance as to who else is out there that is multicast-enabled.
Yeah, I will ping you, Tim, if you're willing to.
All right, what are you volunteering me for?
To
Information on what are
chat.
yeah. And who are the multicast enabled networks out there? Specific, it's mostly the RENs and the NRENs, and you probably know that better than anybody.
Yeah, at least within the European NRENs. We work a lot.
So yeah, we're looking to start sending traffic to more public people, and so we'd like to hook up with those who are doing it and start getting traffic enabled in there. So I'll reach out to you, and thanks for.
Yeah, that's fantastic. I mean, the general problem with multicast, when we look, there is just no evidence of multicast being run across our enabled backbone. It's a lack of content is the main thing at the moment. That means people aren't currently interested.
Yeah, we are trying to get to the point where we can spin up some production traffic. We're not. Right now, it's still a bit sort of R&D-ish, and we're not in a position to be doing like SLAs. So our customers are a little like they're not necessarily unwilling, but they don't want to be relying on it. This kind of thing. So, but yeah, we'd love to get some people using it, especially I think in the research community. It would be a really good fit. And so like traffic that they're trying to get, and when they're connected on these NREN networks, if it was easy for them, for example, with an APT update, and maybe if there was some content that was interesting for them to put into a browser readable thing, it seems like that's a good place to start to get some real traffic going. But yeah, I think we're in the place where like the proof of concepts look pretty okay, and we'd like to start doing some sort of low-end production stuff that nobody cares about too much.
So we're gonna have to cut off, but thanks, Jake, and everybody, please do reach out to him, and review of the drafts would be most helpful. So with that, Lorenzo, you're up, and you can take us home. You have until the rest of the end of the meeting, and since you're kind of in charge of Meet Echo, I'm sure you could buy us even extra time. So you have as much time as you're willing to give us.
I'll do my best, don't worry. By the way, is it okay if I share these slides myself? Because I may have to...
You are more than welcome.
Slides a bit back and forth. Okay, thanks.
Yes.
Okay, you should be able to see the main slide now, right?
Yes, I do.
Okay, so first of all, thanks for the opportunity. It's a real honor for me to be here, especially to speak to such skilled people in a technology that I'm admittedly less knowledgeable about. So I'll try to explain a bit how we actually use or try to use multicast in our own deployments, especially for the purpose of scaling Webrtc deployments. And as you'll see during the presentation, this will mostly cover how we do this basically in an intra-domain. So from a server-side perspective on how to scale things that we then use unicast for. And so it may be possibly a bit boring for you, but hopefully you'll find some interesting things in there as well towards the end of the presentation. And before I can actually explain how we do that, I first have to introduce the Janus Webrtc server. But basically, Janus is a component that I brought a few years ago for our own purposes, and is an open source Webrtc server, which we conceived as general purpose, meaning that it can be extended to do several different things, and I'll cover some of these things later on in this presentation as well. And basically, this open source component is what we build everything upon. So even this conversation that we are having right now is actually being powered by Janus right now. So all of the audio, video, slide stream that you are seeing are coming and going through Janus right now. And these are a few links if you want to experiment with it yourself a bit after this presentation. And just to give a bit the idea of the different bricks that we use to then make all of this possible, I mentioned modularity, and modularity means that we have different plugins that can actually do different things. So for instance, we have the Audio Bridge plugin that is basically an audio mixer that allows us to receive multiple audio contributions, mix them all together, and then send a mix back to each of the active participants. And so basically your traditional audio conference, but Webrtc compliant, if you will. And we have a different approach for video typically instead, where you can use the video room plugin, which is what is typically called in the Webrtc lingo an SFU, a selective forwarding unit. And in this case, video is not mixed. Each video is separate from the other. And so in this case, for instance, you see the video coming from my webcam and you see the slides. Those are two different streams that are being injected in a Janus instance and are then distributed as separate broadcasts to the other participants. And that's true as well anytime more people get their own video and start interacting with each other and so on and so forth. And then we have a third important plugin, possibly the most important plugin for the purpose of this very presentation, which is the streaming plugin, which in a nutshell acts as a very simple rebroadcaster of plain RTP streams. And so I don't know how many of you are familiar with RTP in the first place. So of course, I won't delve too much into details of this, and you don't really need to be that familiar with it. But just to give you an idea, RTP is the protocol that is used to transport in real time audio and video frames over the internet, and is at the very basis of Webrtc as a technology. And so basically you can see a stream of RTP packets being a stream of packetized audio and video frames that are then distributed over the internet. And in this case, the streaming plugin makes it very easy to receive a plain RTP stream and then turn this into a broadcast that multiple people can receive. And this is actually quite an interesting functionality, because RTP is at the basis of Webrtc, but it's also at the basis of several other technologies as well. And there are many components that may not know much or may not be compliant at all with Webrtc, like for instance FFmpeg or partly GStreamer or VLC or whatever, that can actually generate RTP streams that can be consumed in different ways. Which means that if we have ways to generate a plain RTP stream and get it to Janus, then we can make it available via Webrtc to 1 or 100 or 1,000 participants via Webrtc just by doing this simple trick, so using the streaming plugin. And as I'll explain later, this is actually one of the key blocks that actually makes it all possible, and one of the key components that is also important for the multicast aspect that I'll go in a minute. Before going there, I just wanted to spend a few words on how we did IETF meetings before the pandemic started. So as you may remember, whenever you went in a room, wherever the IETF venue was, you saw that we had a camera placed somewhere, that we were duplicating the beamer feed and so on and so forth. And we were doing this so that we had basically a small Raspberry Pi in the room that would capture both of these sources, the camera in the room focused on the chair or on the speaker, and the video being duplicated from the projector would capture these, and then would broadcast these via plain RTP to a Janus instance. And in this case, you can see how the streaming plugin becomes an important component here, because we are taking basically something that knows nothing about Webrtc, like this static camera and this video and this projector splitter, and then we are sending this video via RTP to Janus, and then we are turning this into a Webrtc broadcast, which means that remote participants would then see the chairs in the video, would see the slides and so on, pretty much transparently. So they didn't really need to know that the source of those components were not RTP. And we're actually using multicast a lot in this specific context, because in this case, and it's clear from this other picture probably, basically the RTP address that we were using to broadcast these RTP streams to was actually a multicast address. So we were not sending a unicast stream to the Janus instances. And we were using multicast here for a few different reasons. And first of all, we could because in the IETF venue, we had our own dedicated VLAN dedicated for behind the curtains streaming. And this made it easier for us to basically distribute the media to different servers. And this was not only important to make it available to different Janus instances, which I'll explain in a few slides, but also because it made it much easier to also make the same stream available to entirely different components. And this was important, for instance, when at the moment we had to start supporting YouTube streaming as well. So just to make a simple example, for the plenary, we give the usual access that you see right now as well, but we also allow people to watch the plenary via YouTube as well. And in order to make this possible, we had, of course, to make these streams available not only to Janus, but also to another component that could then act as the video mixer that would then broadcast the video to YouTube eventually. And I'll spend a few words on this as well later. But very, very basically, this would allow us to only send the stream once to a specific multicast address group, and then different components interested in the video feeds from those specific cameras could then basically just subscribe to the group that they were interested in. And so it made the whole process of orchestration and management of the different resources that we had much easier in this context. And of course, I mean, this worked and we were quite happy with this, but then, as you all know, I mean, the pandemic hit and then we had to stop meeting in person, which meant that we had to find a way to basically bring the conversation that we are having in a hybrid approach completely virtual instead, which was the main topic of a presentation that I did in the MOFTS working group at the last IETF. And here is a link to the full video if you want to hear a bit more about it. I'll give a very quick recap of what was there, just to give you the important bits that are needed in order to figure out the way that we can use multicast in this context. First of all, I'm bringing the audio bridge here again. Audio bridge, if you remember from a few slides ago, is the component that can act as a audio mixer for the different streams. And an interesting feature that we added to this plugin was the ability to basically forward externally the current mix that was being generated in a room via plain RTP to a separate component. And we'll see in a minute why this is important. And same thing for the video room. So if I am sending my own video stream to a Janus instance so that other participants, for instance, you can receive it in a browser, at the same time, I can also instruct the Janus instance to relay my video feed as a plain RTP stream to a different address instead, so that it can be used or consumed in different ways. And if you remember the streaming plugin that I introduced before, these two different abilities to relay RTP streams actually provides all the bricks that are needed to implement some sort of a Webrtc CDN, if you will, which was called Soleil in my PhD thesis, because it was the main topic of my PhD at the time. And you can also find a link here if you're interested in having a look at that. And more specifically, this concept of Webrtc CDN that we had in mind assumed that Webrtc was actually needed only at the edges. So you actually only need Webrtc to receive the video from the participant, in this case, me from a browser, for instance. But then how you distribute this video internally on your own network, how you fan out, is completely and entirely up to you. And using features like the RTP forwarding that I just described makes it very easy to then use components that are completely Webrtc unaware for the job, or even multicast networks, as we'll see in a second. The only important aspect is, of course, that if you still want to use Webrtc for the distribution part, you still need to have Webrtc at the edge node somewhere, so that this single stream that I'm injecting actually eventually reaches multiple Janus instances that are able to serve much more users than this single node would be able to. And then in this case, they can all serve their own independent users. And of course, I'm using different colors here, meaning that I could actually inject different streams rather than just one, using the same distribution technology that I have at my disposal. And so used within the context of the IETF, for instance, so how we are using it here, it works pretty much like this. So for the audio part, as I was mentioning, all the audio streams are actually mixed in this platform. And so it means that the active participants are actually contributing to the audio bridge plugin. So they are being mixed. And then this mix is made available via a plain RTP stream to the streaming plugin. And this streaming plugin is then able to broadcast it to many more users. And if we assume that we actually can relay this mix to multiple streaming instances at the same time via plain RTP, it means that we are basically implementing a bare bone version of that distribution tree that we've seen in the previous slide. And we can make the same considerations also for video, with the difference, of course, as I was anticipating, that video is not mixed. So you need to do the same approach for each video that is injected in the platform. So basically treating each video stream as a separate broadcast, which means that, again, we can just RTP forward this stream to different Janus instances and streaming instances to basically fan out and serve more users that we could with a single instance. And of course, this slide basically summarizes how you can do this with two different videos being injected at the same time, which may be using different ingestion points, so different video room instances for actually receiving the media. But then eventually they both feed all the streaming instances that you have available, so that your whole audience is able to receive both of those video streams, no matter where they are connected to. This is at the very basis of this Webrtc CDN kind of approach, which means that putting it together for the virtual events, this is how it works in a nutshell for IETF meetings. In this case, we have a single mixer, audio mixer, that is a reference point for each of the rooms that we are having here. For instance, in this MBONED session, we have a dedicated audio mixer for that. And then the video streams are injected via one or more video room instances instead, so that they are then made available via streaming plugin to everybody. So all of you right now are passive attendees, which means that you are all receiving the video streams that I'm ingesting via a streaming plugin, actually. And this is how it currently works for all IETF meetings. And one of the things that could actually be done, and I was incorrect in saying that we were doing it already in MOPS, I was already chastised by my colleagues for that error, is something like this, which means that this is something that we can do, meaning that since the main purpose is being able to fan out the media that an audio bridge and video room plugin are handling to multiple streaming instances, we can do this via unicast, as I've showed in the previous slides, but we could actually take advantage of multicast for the purpose instead, which means that both the audio bridge and the video room could send to a dedicated multicast address that is basically associated to a specific resource. And then each streaming plugin instance can just consume the resource they are interested into, which means that even from an orchestration perspective, not just in terms of network usages, this would be a great advantage in terms of cost and resources, because it means that if I need a new streaming plugin instance because I need more distribution points to serve more users, I can just spawn a new instance and have them point to the existing multicast resources, and they will pull the resources automatically without me needing to make the audio bridge and video room plugins aware of the fact that I need to unicast this stream to a new component. And this is something that we can actually do, and we have done in our lab for a few times, but we cannot do right now due to the cloud infrastructures that we have available. So for instance, last time we used Azure, right now we are using Google Cloud Engine. But even if we use AWS, none of them have a native multicast support. So there are some of our customers that are able to do something like this using components like Weave and Kubernetes and something like this. But since we use Docker a lot and using our own small technology, we haven't investigated that part yet. But it's definitely something that we want to investigate more in the future, because we want to take advantage of that. And something that I should point out, though, is that if you have, if your own data center or data distribution network is multicast aware, this is something that you can indeed do. And in fact, we do have customers that are involved in the Webrtc broadcasting services that are actually using something like this and are actually pushing it even further. So rather than doing just something like this, where they have ingestion point using multicast to distribute to multiple streaming instances, they are also doing the same with multiple data centers involved. So let's say that you have this kind of setup that we've just seen on one of your data centers. If you want to take advantage of another data center that you have to also increase the amount of audience that you can support, you can do something like this, where you basically have possibly the two data centers that are not connected via a multicast network, but are only available through a unicast network instead. You have some sort of a bridge in the middle. So in this specific context, these customers that we know of are not using AMT as of yet, even though I think that AMT may actually be a perfect use case for these in this context, because the main purpose here is to make sure that a multicast resource is available on one data center, is made available on a multicast network on another data center, so that it can be distributed to even more streaming instances. So this is something that is actually done in production right now by a few companies, assuming, of course, that again your data centers have support for this multicast functionality. And one question that you may ask yourself is, why are we not using multicast everywhere, especially considering that I mentioned broadcast a lot in this presentation. So for instance, I explained how the video streams are basically can be treated as individual broadcasts that are then tied together as a conversation at an application layer. And the main reason is that we basically went for Webrtc from the very start, which was, of course, the obvious choice to make an interactive platform for communication. It's what everybody uses today. It's very simple to use and is available in all browsers, which means that everybody can just open their browser and participate. It means a very low barrier to entry, no need to install custom applications or anything like this, for instance. And of course, unfortunately, multicast is not currently available to all participants, which would be an additional impediment in this case. And Webrtc itself as a technology doesn't support multicast itself, mostly because it was natively conceived as a peer-to-peer technology. And one of the major impediments is the fact that as part of this peer-to-peer communication, there is also a dedicated peer-to-peer secure connection establishment via DTLS, which means that each connection that you establish with a peer, be it another user or a server, you're actually creating an ad hoc cryptographic context, which can not be shared among multiple recipients in this case. So as a technology itself, Webrtc is currently not suited for multicast usage. Even though Webrtc, among the technologies that Webrtc makes use of, there is also a bit of multicast, because due to a few privacy considerations issues, there is actually the usage of multicast DNS to advertise candidates in the SDP that are being exchanged. So there is a bit of multicast in there, but this is just for connection establishment, not for actual multimedia delivery. Even though I guess that some multicast would actually be leveraged more from a broadcasting perspective, and especially possibly with the usage of AMT, as I was saying before. And the basic example here would be broadcasting as we intended in a more broad sense. So I was mentioning before how we can actually make some working groups available via YouTube as well. And I was making the example of the plenary, for instance. And it works pretty much this way. So you have multiple participants interacting with each other, that if you are connected to the Miteco interface, you see as you're supposed to see, so with the different streams appearing and disappearing as different streams. But we also have a separate component, a mixer/broadcaster, that is receiving in real time all of the feeds that are being contributed to the room, is composing them into a single audio video feed, and is then publishing it via typically RTMP to a CDN so that it can be broadcasted somehow. And in this case, for instance, so that it can be visible via YouTube. Which means that one possible evolution here might be to actually take advantage of AMT for the purpose here. So the moment that we have a stream that we can broadcast and distribute in real time, even though there may be a bit of latency involved, these broadcasts may be made available through an AMT relay, for instance, so that it can be consumed by multiple multicast recipients somehow. And right now, this is mostly, let's say, a thinking out loud kind of slide. We don't really have anything done in this context, but it's something that we are thinking about doing in the future, sooner or later. And just one last slide, just to tie to the presentation that Oriol was making before. There is actually some interesting efforts being done within the University of Naples. So you may not know that Miteco as a company was actually born as an academic spin-off of the University of Naples. We all got our master thesis and PhD there, and we still have some connections with the university. And for instance, Simon Romano, who is part of Miteco, but is also a professor at the University of Naples, acts as a tie-in for these kind of activities. And one of the activities that we've done there is actually a project called Shine. So we contributed a bit to this aspect as well, mostly because Shine allowed you to do pretty much something like I described so far in terms of the fan-out distribution using an architecture as a Soleil, basically a tree-based distribution, but then using satellites and multicast networks in order to expand the distribution even further. And I mean, if you have any question on this specifically, Simon can probably be much more responsive than me on this context, but I just thought I'd contribute some information on this as well, especially in case it may be of interest to you all. And I hope I made it in time, so I hope there will be some time for questions. So if you have any, I hope I didn't speak too fast as I usually do, and I hope that you'll have some interesting questions for me. Thanks.
Sure, Jake, you're up.
Yeah, hi, thanks, Lorenzo. That was great. Would you be interested in like, what do you think of porting the I forget which piece it was called, but there's so instead of using WebRTC, trying the browser API to receive multicast, and then feeding the RTP into, I think you can do it in the what do they call it, the SRE, the media, no, there's like browser APIs to actually display the media, right? You're familiar with these? Like, have you looked into porting to WebAssembly?
Yeah, this is something that we are starting to think of also, because it's probably going to be what some time ago was called the WebRTC NV, so the new version of WebRTC, where they are trying to learn about the mistakes from WebRTC first version and try to improve in the next one. And so one of the ideas was basically to try and possibly use Quick, for instance, rather than use RTP and anything like this, to then transport media in different ways over Quick, and then, as you said, use WebAssembly to both encode streams and decode streams on the way back and forth. We haven't done this yet, even though there are some people already working in this direction. So, for instance, if you take the Zoom web client, for instance, it's WebRTC only in quotes, because they actually don't use WebRTC much at all. So they actually only use the APIs to capture media and then encode stuff themselves in the browser using WebAssembly and exchange stuff on their own, rather than doing WebRTC. In this case, for us, it would be a bit more complex than that, because it's not just a matter of packetizing and so on, but we would lose a lot that the browser gives us natively for the moment. So right now, all we need to ask the browser to do is basically ask you for permission to access your microphone and webcam. And then once you do that, it's the browser itself that actually captures the component, does the encoding at a much lower level that is not accessible to JavaScript, and takes care of distributing the streams back and forth, and takes care also of the feedback mechanisms involved in terms of bandwidth estimation, negative acknowledgements, and all of these kind of things. And this is something that is very powerful and is done not at the JavaScript level, for sure. So it's something that is done at a much lower level, and basically frees us from many of the complexities that are involved here. Of course, some of those complexities we have to take care at the server level in order to take care of the feedback involved and these sort of things. But from a client-side perspective, it's much lighter. The moment you start using WebAssembly, it means that you need to worry about encoding stuff yourself, which the more streams you encode, the higher the CPU usage will be. And no more how optimized WebAssembly is, it will probably still be a bit heavier than it currently is done at the C++ level by the browser itself. And same thing for the decoding part. So it is possible in practice. For the moment, I think it's a bit premature, because just because of the usage of resources that may be involved, that may actually a bit too high. But this is something that we definitely want to keep track of. And for instance, I was interested in your presentation before just to see what we could do in using multicast directly from the browser, to see if there could be some step that we could do in order to avoid WebRTC in some cases and use multicast for the purpose instead, which may be useful, for instance, even in the context of just attending an event, for instance. In this case, there's no encoding involved. Decoding may be much more lightweight. In this case, receiving a broadcast would be much easier to do and easier to perform. But yeah, in very long story short, it's something that we would like to do, but we haven't any immediate plan to do. So we are following the evolution of the standards in this sense.
Okay. So your clients don't do any, you don't have a client that's not a WebRTC then? That sort of
because everything goes through Janus in our case, and Janus is a WebRTC component. So what we definitely want to do is, as soon as Quick becomes one of the alternatives to communicate via WebRTC, we want to start using that as well. For multicast, it's a bit more complex than that, which is why, for instance, I mentioned this potential idea over here. So this may be a first step that we could take in order to familiarize with the technology and see if we can take advantage of multicast also for just plain broadcasting, which is still a very common use case. I mean, the IETF is a bit more of a different use case when compared to other events that are much more one-to-many oriented. The IETF is much more cooperative and collaborative, and so much more interactive in this sense. In scenarios where we are more interested in broadcasting than actually active participation, it's something that we want to start investigating a bit more.
Yeah. All right. Thank you.
Lorenzo, for this model, what would you say are the gaps? Because this seems like this is exactly what IMT was built for, and what would it take to get to be able to deploy something like that?
First of all, I would have to familiarize myself a bit more with the technology, because I've read a bit about it, but I'm admittedly not that much knowledgeable about it. So I want to study a bit more about how the technology works, especially within the context of live distribution, so not just distribution of static files or something like this. So what can be done for the purpose? I know that, for instance, I think it was you that were involved in integrating this support in VLC as well. So that might be an interesting thing to look into, especially for the attendees' perspective. So how they can actually consume a stream that we are introducing that way. In general, it's a matter of figuring out how media should be encoded and packetized in order to distribute it somehow, and what can be done in order to minimize the impact on the recipient side so that they can reuse existing tools rather than writing ad hoc tools for that as well.
Great, and I just added into the comments for a little more information about that VLC port and how we're using it in the multicast menu. It's a good primer to see all the pieces in place. That multicast menu basically lists all the active multicast streams on the MBONE, and you can just click on them, and it'll launch VLC. If you have the correct VLC, the latest version of VLC, it'll run AMT capable, and you'll be able to watch over AMT.
No, thanks. That's very helpful, because I just need we just need some reference to know what we should basically construct in order to make it compliant with what is out there. So basically, to reply to your point, what's missing is we need to do some homework. Basically, that's it.
Right. And I'll say this, that the multicast menu, we're looking for way more content. So if you've got test streams, if you've got real streams, even better. We'd be happy to add them to that. So
okay,
content is king. Any other questions for Lorenzo? All right. So I guess if that's all, I'd like to say thanks everybody for joining, especially those on the West Coast of North America who had to wake up extremely early for this, and look forward to hopefully seeing everyone in person maybe at 1:11. We can only hope, but we'll see. Otherwise, we'll see you in a couple months.
Thanks, everyone.